So this session is Minibytes session 14, where our aim was 21 in 21 days. We're on target for that. We're currently at 2/3 of the way through. Minibytes session 14 is about the primary computing curriculum for new coordinators. So what these 21 minutes will cover is very briefly everything in the primary computing curriculum, but we'll be touching base. This is a truncated version of a session which I can do in a 1 hour or 2 hour twilight training course. If you're interested in that, you can contact me. Details are at the end. But otherwise, let's crack on and begin. So as we look at the primary computing curriculum, it changed a few years ago, and ICT in a whole is a big mess. So if you look at this, you do not need to copy out this diagram. This is just showing all the potentials and possibilities that you might be covering across ICT as a whole, information communication technology and pedagogy, as in the teaching and training of things. But in actual fact, the curriculum is only a few bullet points long. If we get away from that web of complexity and rein it back in and look at the actual curriculum itself, we'll find that there's relatively few bullet points. The Key Stage 1 curriculum has got 6 bullet points, and although they are wordy, the paragraphs themselves do make sense. I've just cut them down even further for these slides just to show actually what the key points are. I'm going to go through each of the Key Stage 1 and Key Stage 2 bullet points from the curriculum in brief, just to give an outline of context. The intention being that if you're a new coordinator or you're refreshing yourself on the computing curriculum, it gives you a good starting point and demystifies some of the primary computing curriculum. So that's Key Stage 1 there and Key Stage 2 here. I'm not going to read through these at the moment because I'll be talking about them in depth over the next 20 minutes or so. As we see through the descriptors, there's quite a lot of overlap, and it lends itself really well to being a spiral curriculum where you revisit things over a number of years or over a couple of key stages, and the spiraling will increase in complexity of what's being attempted or what's being shared and learned with the pupils, but also it will allow that chance to revisit prior learning. It'll give you the chance to revisit prior language and then develop not just the complexity, but the breadth of use as well. So the applications in different environments. Let's have a look through. In the first point in the national curriculum for Key Stage 1, the blue ones are Key Stage 1, the green are Key Stage 2. You'll see that it's understanding what algorithms are, how they're implemented as programs on digital devices, and what programs execute by following precise and unambiguous instructions. So this often gets a bit of a worry, because what's the difference between the two? When an algorithm is a step-by-step procedure. It's written for a human to understand. I will show you some in a moment. It's often a flow chart or some sort of graphic diagram. A program is different because it's a particular set of instructions in a particular language, so that task is performed perfectly by the computer, or imperfectly if the program's got a problem in it, which we'll come to later on. So the set of instructions is language specific. If you have a computer that only speaks French and you do not program it in French, then it will not do anything. If you have a computer that speaks only Chinese and you program it in French, it will not do anything. You need to pick the appropriate language. Now, the thing is with programming is the languages aren't called French and Chinese and English. They're called things like C or Python or Scratch. It's just a programming language name. Let's move on from there. Simplifying it a bit, here we go. We have an algorithm is a flowchart of how to make a sandwich, for example. But a program would be very specific instructions. I'm going to show you a link to a video, and I'll put it in the chat later on, which is a chap called Phil Bagg, who's a computing advisor and teacher, and he's used the jam sandwich robot model, where essentially the teacher in front of them has different resources and the children give explicit instructions. An algorithm from a different subject area will be column addition. So you know the process to go through for adding up your numbers. You follow this step, this step, this step, and you end up with the sum being completed. And daily routines for an algorithm as well. So wake up, get up, brush teeth, have a wash, get dressed, have your breakfast, go out the house, walk to school, get to school, done. That would be a morning routine. You might then have a daily routine of your timetable to follow. All of these things are algorithms. They're not specific. It's not saying how many times and in which angle to brush your teeth. And it's not saying in which order you put left foot or right foot as you get to school. But these are all algorithms. They're general gists of programs. The programming in particular, we've talked about Phil Bagg's Jam Sandwich Robot. I'll mention that again in a second. But Scratch Junior, which I've already done a 21 and 21 Minibyte on, Scratch itself, but Scratch Junior as well, or the B-bots, the physical robots, can be programmed to do specific actions when you press specific buttons. So that's all comes through programming. This is a screenshot of Phil Bagg's video on YouTube. The link is there. I'll paste this text in the chat later on, but I'll leave it on screen for a moment if you want to watch it yourself. And this video is great because he's got all the content. He's got a knife, a plate, jam, bread, butter, and a bag of bread as well. And behind him on the screen, you can't quite see, but he's got the key words. So left hand, right hand, and different words like spread and different nouns like jam or butter and so on. And if the children give him a specific instruction using specific nouns and actions, they are programming the teacher robot, and that teacher robot then either makes successfully or unsuccessfully makes a jam sandwich. And you can see there's great fun involved. Another task for algorithms could be making a challenge like this, a 3-tier task, and I'll show you some examples of algorithms in a moment. But comparing algorithms, and they can start off simple and get very difficult very fast, is often the first step. The second step is writing an algorithm, so writing a flowchart, and then the third task is about writing an algorithm for something similar but a different example. I've used the snap card game, where you paste a card of the same value and you say snap, versus the memory card game, where you turn over 2 cards and try and match a pair and then carry on going. This is an example of a tiered activity you could do with your children. This is a very poor to read snap algorithm there, but you've got decision making diamonds, you've got squares which are actions, and you've got a starting rounded rectangle. And this is saying basically, is it your turn? Yes, play the card. Is it the same as the previous card? No. Then end your turn as such a person and carry on going. If it's a yes, you complete the snap action. And did you win it? Yes or no? It can get more complicated, and this is snap in a more complex way. But I'm not going to focus on that for now because it's really difficult to see through a screen. It's better to do it in person. Programming is different to algorithms because the language you use, or the actions you use, or the icons you use in this case, are critical. So in this program, this is using Scratch Junior on the iPad. You've got a green flag, which is an action. So you click on the green flag, and then you can see the cat was going to move forward and then jump a number of times. You've also got a different one here where if you click on the cat, it will rotate and then counter rotate, and it will do that 4 times in a row. So this is programming made easy. It's a drag and drop system, and it's very useful for a very low risk but high learning factor experience through programming. And then you can set the challenge of what do you want the cat to actually do and see if you can make it do it. The next part in the curriculum is about logical reasoning to predict the behavior of simple programs. You can do this in maths all the time. So 4, 8, 16, 32. What's the next number in the sequence? That would be mathematics. But in computing, you can do something like this. If you get given this program, repeat it 4 times, move forward, then turn right 90 degrees. What shape do you end up with? That would be a square, but you can have different programs for different shapes. And you can go through this in year 1 and year 2, children understanding that devices can be controlled by buttons, and children understanding that their actions on screen can be controlled by sequences of actions or instructions like this at the bottom. You can just go through logical reasoning from maths and carry it into computing. Here's some examples of other tools you can use. I'll not go into them in depth right now, but you'll probably recognize a screenshot or two. That's a physical B-bot. That's the B-bot app, which does the same tool set and the same button set. And you've also got tools out there on the internet if you search for them. Purple Mash, for example, has tools as well. But musical instrument activities as well can be used for programming. Google have got a nice music lab online free tool, which is similar to this screenshot here. And you can see different products from different environments and different companies. Search for it and find it and have a play. But if it involves putting things in an order, then you are programming. Number 4 is using technology purposefully to create, organize, store, manipulate, and retrieve digital content. That's quite a beast of a phrase, but if you look at it in its chunks, you can have storytelling, so through Scratch or telling a joke. I did a Scratch telling a joke as a previous Minibytes session. You can do music because that's all the notes and hopefully in the right order to make music. You have science, you can do sensing, you can do thermometers and that sort of thing. You can use geography for mapping and directions. You can look at your PE with your robot. and so on. I like to do something called B-bot curling, where you set a target on the floor and you program your B-bots to get as close as you can to the target spot, and then you can put obstacles in the way. There's also maths tools, or you can do Christmas cards and Christmas activities based on programs. Number 5 for Key Stage 1 is looking at the common uses of IT beyond the school. So I've put a picture in there. Traffic light crossings are brilliant for modeling, but also for seeing a real world application. You press the button and then you wait, and then the green man changes and comes on the screen after the red, amber, green process. So you can get children observing and making notes and taking skills on that. But you can also have a question about how do you get in your supermarket with its automatic doors? If the doors are opened and then stay open, they're not doing their job. If the doors do not open when a person approaches, then they're not doing their job. So unpick that and use normal everyday language to figure out what the algorithm is for the doors to open when you approach and close when you've gone past. And there's going to be some sort of sensor in there as well. And you can start to introduce phrases like loops, which means that you'll sense if there's still a person there. The loop is keep the door open and sense again. There's other tools like we've got our smart speakers. I'll not name any in case it triggers your house or your school for smart assistants, but we've got these tools here which are on programs and are running algorithms all the time. And you've also got things like autopilot on airplanes or cruise control in cars, which fix the speed. All of these tools are dependent on sensors or some sort of input and an output. Safer Internet Day is fab. This is actually the last year Safer Internet Day. Apologies for that, for the picture. But Safer Internet Day covers most of these things about using technology safely and respectfully and keeping personal information private. A good example is about your toothbrush. You keep your own toothbrush for yourself. You don't share it with others. And that's a starting point. And then you might move on to other things. Well, what else do you not share with other people? And you can talk about good secrets like passwords and bad secrets. And you can get into PSHE and cross-curricular links with relationships education really easily with this as well. There are various hints and tips and barriers which you can overcome through having these conversations. It's not just about doing something on a computer, it's about the greater learning beyond that computer device. Moving into Key Stage 2 now in our 21-minute update, you've got design, write and debug programs that accomplish specific goals. So this is working above and beyond what the Key Stage 1 program was. Designing means an algorithm. It's drawing a picture and putting in your own words to make sense. It could even be pictograms if you choose to use pictures. For example, robot arm actions might be pictures instead. Writing is programming the code so the algorithm works, so it does what you expect it to do. If I want a cat to jump and I press space, then I need to program it so when I press space, the jump action occurs. Debugging it is seeing if it works. If it doesn't work or if it's not correct, then try again and change things. Debugging is one of those things you do in English all the time. It's called drafting your work. Debugging is drafting your program. Control is making it so an input produces an output, for example, the spacebar and the jump action for a cat, or an indicator on a car for turning left. You flick the lever down and the car indicates left. That would be a control. And decomposing is making use of smaller programs to nest into a bigger outcome. I showed you a decomposed program earlier on, which was the drawing a square. You move forward and you turn left 90 degrees. You repeat that 4 times and you've got a square. So it's just 2 lines of code and a repeat over the top of it. And that allows you to make use of smaller programs. You can also then develop further subroutines like the snap subroutine in the game Snap, and that's about how you win and how fast you move your body. You can see examples here of a banana piano using a makey tool, and Scratch programming allows you to make a banana piano where it works on the conductivity of your skin. You hold onto one wire and you tap the bananas and they're linked up and programmed into certain notes. And now you've got a musical instrument made from fruit and programming, which is amazing practical computing. The other thing is Legos has sensors. They've got their crocodile robot, which if you put your finger in its mouth, it will snap shut because it's got a light sensor in there. So this is all about programming and how you use it, and also about how you get your bananas in order, because those bananas are touching and therefore you'll get some sort of cross-contamination of the note. Works in the photograph though. The next one, point 2 in the Key Stage 2 national curriculum, is using sequencing, selection and repetition and working with variables. So sequencing is in the right order. I do not put my toothbrush in my mouth, take it out and put toothpaste on because that's the wrong order. You do it the other way around and that's the correct sequence. It's important to get the sequence in the right place. Selection is about picking the answer. So this is reflected in school life. If you say hot dinners or packed lunch, if a child identifies that they want to pack up, then you don't send them to the hot dinner queue. So that's a selection process there. Repetition is also called a loop in programming language, and this is about repeating something a number of times until something else is achieved. So it might be repeat a number of times until that number is reached, or it might be repeat until a certain color is touched on the screen, or you collect all the stars, or whatever your objective is for the program. A variable is a placeholder for a value that can change or could be changed. In maths, this is often x or an empty box. So 3 plus empty box equals 7. Then the empty box is your variable, and it can be correct or incorrect. But in programming language, the variable might be the color that you're touching. It might be the input received, so which key you press and so on. That's what it means. And the input and output, an input is something that goes into the computer to give it some information, and the output is the response provided by that computer or program. This is an example here which includes those things of sequence, so you can see things are in order. So pointing towards the mouse pointer, moving forwards. If you're touching the sprite, then you add 1 point, and that happens forever. So this is going to create an object when the green flag button is clicked, the score is reset, and then it keeps on chasing sprite 2. OK, that's what your mouse is going to do and try and get sprite 2. That uses all of the previous things in one go. The variables on this screen are the score and the sprite 2. The outputs are the changing the score by 1. Logical reasoning for simple algorithms. I'm not going to go through each of the year group points in here, but you can pick the one that appeals to you most. But basically, it's all about different sequences can achieve the same outcome. So this means that you can have many different ways to have the same outcome. You might want to prepare some fruit. You might peel it, or might want to prepare a potato. You might peel it first and then cut it, or you might do different ways. Either way, you still get an edible potato at the end of it. It's quite good for recipes when you mix in dry ingredients followed by wet ingredients. The recipes might vary. It doesn't matter if you put in flour before sugar or after sugar in some recipes, but it does for others. I'm not going to look at all these in turn because we're running very tight on time. Understanding computer networks, including the internet. There's a few useful videos out there, so again I'll put these links in the chat. But the internet is basically a large connection of many computers. Those computers, if they do nothing else involving people, are often called servers, and those servers are there to provide a service. That service is a program running on top, which is the internet. We access the internet through modems or through routers in our home, and that means that our personal Wi-Fi, our personal computers, or school computers are linked via either Wi-Fi or wires to a router, and that router is connected via wires to the internet. And the internet is not a cloud, even though we call it cloud computing. The internet is not a fluffy thing in the sky. The internet and cloud computing is actually a lot of someone else's computers somewhere else in the world. And you can talk about the ecological impact of that. So how you power it, the emissions of both heat and carbon dioxide, and any waste energy, how that's linked to it. Finally, number 5 out of 7 is using search technologies effectively. So I've put a number of key phrases or words on there when you're Googling stuff, or using any other search engine, Bing and whatnot. You can use and or. You can use speech marks or a dash, which in this means minus, which is take away certain options. So for example, if you're searching for wolves minus football, you would not get Wolverhampton Wanderers, but you would get the animals. If you search for wolves minus animal, you would get Wolverhampton Wanderers and not the animal. Using tabs, the site colon gets this particular website as a search, and there's various other phrases out there. The only one which is not searchable is kiss then detail. So it's keep it simple, and then what you do is you keep it simple. Stupid is why I know it has there are other phrases out there, but if you keep it simple, if you get too many results, you can then add detail in little bits, and that will shorten your results string. There's a nice challenge called a Google Whack. The comedian Dave Gorman did this. The Google Whack is typing in 2 words into a search engine. You can guess which one he used, And if you get one outcome, one search result from your 2 words, that's a Google whack. It might be worth a good challenge because it gets you searching effectively. You can add more and more phrases of these blue blocks to get there. Number 6 is designing and creating a range of programs, systems and content to accomplish given goals. And this might be including controlling a robot to deliver foodstuffs to animals, obviously in a model environment. It might be changing variables to change the scale of things. Or it might be making something else occur. It can be practical computing, or it can be on-screen computing as well. So you can use a number of variety of tools out there, including Scratch. But there's also Lego WeDo, for example, or you've got Makeys out there to make these banana pianos, and so on. So it's having that range. Start with something simple and build it from there. Finally, point 7 for the Key Stage 2 curriculum is the same as the Key Stage 1 curriculum, about using technology safely, respectfully and responsibly. And by doing this, it's recognizing acceptable and unacceptable behavior. You may have focused on this during lockdown times and remote learning, but it's always worth revisiting consistently about actually, would you be happy if, for example, a grandparent saw that picture, and if not, then don't put it online. And you've got that private and you've got the personal, and sometimes you have to share personal information, but you don't share private information online. So it's having that wiser look. So what you do, I've gone about 1 minute over, but I'm sure you'll bear with me. Look at what you've got in place already and what you can develop. Think about what you need to start or to get in place in order to begin, and what can you do next week. There's a website called stem.org, which has got lots of resources there on the primary computing curriculum as well. I'm not going to go through this in detail, but there is the EEF, the Education Endowment Foundation, has got lots of guidance, but basically it says look before you leap and plan before you do. I'll leave that there for the YouTube video watchers later on to read in detail. And then the final part here is just my details here. Schools ICT are on Twitter, and I'm on Twitter as well with those details. Schools ICT is North Yorkshire Schools and is North Yorkshire's local authority traded service that covers all these things like training, Office 365, support, shop, websites, and MIS, as well as a technician service for those in the geographic area. But we're also working with North Yorkshire Education Services, or NES, and I'm part of the EdTech service, which is the application of all these tools. So with together we're going through a rebranding. It's going to be NYES Digital or NES Digital pretty soon. And I'm going to stop presenting there. I hope it's been useful to you.